Hi everyone, thank you so much for attending my talk today about cannabis laboratory testing workflow from receipt to results. Just a quick introduction of myself. My name is Carly Barone, and I am the chemistry lab manager of a cannabis testing laboratory located in Colchester, Vermont, USA. Just a quick overview of what we'll be discussing today. We'll start with a brief introduction of cannabis. We'll go through testing workflow starting from receipt through processing, data analysis, and reporting results. And then we'll finish by talking about some challenges we face in cannabis testing laboratories and how we can move forward. One term I will be using throughout this presentation is cannabis, and this includes both hemp and marijuana. Both belong to the genus Cannabis and can be described by three species: indica, sativa, and ruderalis. So what's the main difference between the two? There's some morphological differences in the flower. Basically, it's a difference in the amount of THC or chemical makeup of those plants. And federally, hemp is described as being less than 0.3% delta-9 THC based on dry weight. Just a quick overview of the history of cannabis. Cannabis actually dates back about 6,000 years to 4,000 BC in China when it was actually used as a food crop. But today we will just be looking at the past 50 or so years, starting in 1970 when cannabis was made illegal and classified as a Schedule I controlled substance. In 1996, California was the first state to legalize the medicinal use of cannabis. And in 2014, President Obama signed the Farm Bill, allowing hemp to be cultivated for research purposes. Very recently, the Farm Bill of 2018 was passed, federally legalizing hemp and hemp-derived products. And today, specifically where we are in Vermont, adult use and medicinal marijuana use are legal, but the recreational sale of marijuana is not legal as of yet. So there are countless matrices that contain CBD and THC. You name it, there's probably a product out there. We see anything from dog treats to gummies to bath products, and all of which need to be treated specifically in our laboratory. And not only do we see a lot of different matrices, but cannabis itself is a very complex matrix. Cannabis actually contains 545 compounds, and 104 of those are cannabinoids. So while cannabis is an extremely complex matrix, and we see a whole slew of different matrices in the laboratory, we also need to not only look at cannabinoid potency, but we're looking at a list of contaminants as well. So these include residual solvents, terpene profile, heavy metals, pesticides, microbials, and mycotoxins. With this long list of compounds, we really need laboratories that are able to test accurately and quickly, and this is done using a workflow that is efficient and one that works for that laboratory specifically. So the first part of our workflow starts with us receiving a sample. So the second the sample comes in, they are labeled with a unique identification code or a barcode, and the corresponding information is entered into our system. We want to make sure that we have the customer information, sample information, the tests that are requested by the customer, the sampling date, and the submission date. So here's an example of our sample submission form in our laboratory. You can see on the top of the form, we have all the customer information. Our sample is described below, as well as what tests are requested for checkboxes you can see there. And also we are asking what the matrix is of the sample. There's also billing information on there for invoicing as well. So first things first, when we receive a sample, once it's checked in and put into our system, we first want to put these samples into categories. And this helps us move forward with our process. So we can really place things such as gummies, oils, and chocolates into a low concentration category. We place our flowers into the medium category, and then isolates and concentrates will be described as high concentration products. And no matter what the matrix is, everything is going to start by getting homogenized. So this allows us to take a representative homogeneous sample of the submitted product, and this can be done differently in laboratories, either using a grinder, liquid nitrogen, stainless steel agitators, or cryogrinder. So once the sample has been checked in, homogenized, and weighed out based on whatever test we are testing for, we are then going to extract it. So even though we had categories where chocolate and oil end up in the same concentration category, those are actually going to be extracted differently. So samples are extracted according to the specific matrix. And as of right now, laboratories are doing this differently. So far, AOAC has approved an official method for cannabinoids, and they're working on many others, but this is the only official approved method so far. Once everything's extracted and ready to go, we are ready for analysis. As I mentioned, we analyze for cannabinoids, terpenes, residual solvents, heavy metals, pesticides, mycotoxins, and microbials, and all of these are done differently. We can have a sample come in that is solely for cannabinoid testing, or we can have a sample come in that needs a full panel. So we'll first look at cannabinoids. In our laboratory, we're testing cannabinoids using high-performance liquid chromatography, or HPLC. And this can be tested with many different methods. Some laboratories are using GCMS, some laboratories are using LCMS-MS, or other methods. In our laboratory, we're looking at 12 main cannabinoids, and other laboratories will look for 6, some will look for 16. Depends on what the customers are looking for and are interested in seeing in their products. We also are reporting total THC and total CBD based on these numbers. And so federally, we know that the action limit for delta-9 THC based on dry weight is 0.3%. Here in Vermont, Vermont has actually set a 1% limit on total THC. And then if we're looking at moisture content, which plays a role in all of our analyses, we want our trim flower, and this is all specifically for hemp here in Vermont, to be 13% moisture and 0.65 water activity. Next is residual solvents. Residual solvents are found when a cannabis product has been extracted using some type of solvent, and this needs to be removed before the customer actually ingests it. So we are testing to see if there's any solvents that are left over. We are using gas chromatography mass spec to do this because most of these compounds are pretty volatile. And you can see the state of Vermont has set limits for a list of residual solvents that we do not want to see show up in customer samples over these limits. Using GCMS, we're also testing terpenes because they're also volatile compounds. We're looking at 22 terpenes to include limonene, pinene, and caryophyllene. While this is not one of the regulated list of compounds by the state of Vermont, basically because it is not associated with potency and is not considered a contaminant either. We are still looking at these compounds because customers are interested in seeing their terpene profile. The importance of the terpene profile for customers is that not only does it give the aromatic signature of that product, but it also has been shown to contribute to the entourage effect and have some medicinal benefits. Also looking at heavy metals. For this, we are using ICP-MS technology, and we are looking for 4 main metals. The importance of looking for heavy metals is that the cannabis plant is actually really good at uptaking heavy metals from the soil. as well as from any agricultural water used. So the state of Vermont has set limits for, action limits for flour, as well as a list of limits for concentrates products and infused products. Next, we can look at pesticides. We are using liquid chromatography, dual mass spectrometry for this. And with this technology, we are able to look at 60 different pesticides. Pesticides are important because they are being used in the hemp arena and the cannabis arena, just like they are in most crops. And the state of Vermont has a pretty comprehensive list here of 15 different pesticides, but I know that other states are actually looking at 90 plus pesticides, so this is a rather short list compared to those states. We are also looking at microbials. So we have a couple different methodologies that we use to look at these. When looking at total yeast and mold and total aerobic bacteria, these are quantitative methods used on plates. You can use petrofilm, and these are plate counts essentially. We are also looking at mycotoxins. We use LC-MS to do this quantitatively, and on the LC-MS we can test for aflatoxins A1, A2, G1, G2, as well as ochratoxin A. There are also specific bacteria you can test for. Aspergillus, which is actually a fungus, those different species can actually be tested for via PCR. These are qualitative tests usually. And the state of Vermont has set limits for microbials. We have different limits for trim flour, different limits for concentrates, and different for products and infused products. So once everything has been analyzed for the requested tests, we do a final check on all parameters. So that's making sure that our blanks are blank. It's making sure that our controls and check standards have come in at the correct concentrations that we're expecting them to. We want to make sure that our calibrations are linear, and we also want to make sure that in our chromatogram and spectra that our peaks are showing up at the correct times and that they are being identified correctly. If we have to double check, we can always use NIST to cross-reference for some of our testings. So once all the results have been validated and approved, we can then move on to generating reports. And this comes with a whole list of its own approval and checklists. But once the report has been generated and checked, we can then release that certificate of analysis to the customer. One of the main points here for the customer is to make sure that there are explanations. So for example, on our reports, we have a small box that gives a explanation of how total THC is calculated, how total CBD is calculated, how the percent moisture plays a role in their results. And this is really important because this is a fairly new industry. We have farmers that are new to the industry. And so sometimes that means a phone call. Sometimes that means some supplemental information for people. And just to make sure that they understand that what their results mean for their product. This is really important for them because the state of Vermont has set limits for what their results should be compared to the label value that they're placing on that product. One really great resource for cannabis testing workflows are LIMS software. So LIMS are really great at data management, generating reports, and keeping everything really organized and flowing smoothly. So there are LIMS systems out there that are specific to cannabis laboratories and will really keep your workflow efficient and working correctly. So once everything has been generated and given to the customer, billing and invoicing will be done. and then we will store the sample for future use or disposal. So what are some challenges that we're facing currently within the cannabis testing workflow? One of the biggest ones is the lack of data, the lack of validation work done. There are few standard methods. As I mentioned, the AOAC method for cannabinoids is one of the only ones out there right now. And we are, like I mentioned, the different number of matrices that we're seeing do pose a challenge in that it definitely expands the number of extractions and the amount of work that is done during your workflow of processing. Additionally, there are big variances between laboratories, and this is probably due to the lack of standardization, which is a huge problem. So like I mentioned, a lot of laboratories are using different extraction methods, different techniques, different instrumentation to test for the same things. This just causes variance, and we see that between laboratories, and as well as you can see variance in sample prep, so how the customer has sampled the plant can cause some variances in the results that you're seeing, human error, sampling size, and then also, once again, going back to the fact that cannabis is a very diverse matrix, and this is just making everything even more challenging. So some things that we can do moving forward as cannabis testing laboratories. AOAC is a great organization that is working really hard to standardize and create standardized methods for this industry. Like I said, they have already put one method through, and they are actively working on many more for contaminants as well. And if you're not familiar, they have a program called CASP, C-A-S-P, which they are working very hard on improving the standardization of the cannabis industry for testing. Additionally, a great resource for laboratories is becoming ISO 17025. This is an accreditation body and a regulatory body, so essentially making sure that all of your methods are validated and you have a quality control system in place. ISO 17025 is great for laboratories, as well as, for example, in our state, we have a cannabis quality control program, which is similar to ISO 17025. And for our state, the regulatory body is the Agency of Agriculture. In other states, it's different. But this is essentially the same idea, validating methods, as well as keeping a quality control system in place. Additionally, moving forward, seeing more validation studies will improve either inter-laboratory or multi-laboratory studies, solidifying regulations, as well as more laboratories becoming ISO accredited, as well as certified laboratories within their states. Proficiency testing is another great point to touch on for laboratories. This is great for making sure that your laboratory is providing accurate results. It also allows you to compare with other laboratories and just allows the laboratory to make sure that they're doing things correctly. Making sure you have a quality system in place is really important for laboratories, as well as standards and method development, which AOAC is doing a great job pushing forward in this industry. And I think the most important part of all of this is the training, education, and outreach for laboratories and laboratory scientists and technicians, and just making sure that everybody's on the same page, working towards the same goals, and like I said, standardizing it so that we are all producing accurate quality data, and making sure that in between laboratories, things are able to come out looking the same. And moving forward, basically as this industry grows, we just want to make sure we're growing with it as a laboratory too. So making sure you're staying up to date on all of the newest methods and staying up to date on how you can continually improve your laboratory workflow is really important. This is an ever-changing thing, and we're always changing and improving and making sure we're growing with this industry. And feel free to email me or ask any questions. Thank you so much for joining me today.